Hello, my name is Julia Bealsmith. I'm the product manager for biosolids, and this is the employee orientation THERMO-SYSTEM presentation. The THERMO-SYSTEM active solar dryer has a more system approach to it. The major components are the concrete basin, the transparent enclosure, the tilling device, a flap on the front of the solar dryer, and fans on the rear, weather instrumentation in and outside of the solar dryer, and a microprocessor, and a programmable logic control unit. The THERMO-SYSTEM active solar dryer is utilized mainly to dry biosolids or sewage sludge, but there are other uses, water treatment plant sludges, effluent from biogas plants, wood, and other residual materials. The energy savings that are realized with the active solar dryer is because the majority of the energy utilized is from the sun. 95% of the energy comes from the sun. The tilling device, the fans, the microprocessor, and the instrumentation use about 5% that comes from the grid. The THERMO-SYSTEM active solar dryer has 200+ installations in the United States, ranging from 200,000 gallons per day to 80 million gallons per day. There are 20 sites in the United States, and we currently have 56 moles in operation. This is a drinking water installation in Hawaii. This is as far out west as we will go with Parkson. This is a picture of Kent County, Delaware, and this is the glass Venlo design that we have utilized here. This is the polycarbonate design, so you have option of glass or polycarbonate for your transparent material that covers the solar dryer. The white building out front is an example of the control building that would be utilized with this system. The batch operation concept is the primary operation that we will utilize because you can achieve Class A biosolids through this process. The process utilizes the control air inlet flap and the control air exchange, which are the fans that are on the back of the solar dryer. There are climate sensors inside and outside the building, and the tilling device keeps the sludge aerated, turned, and mixed in order to accelerate the drying process. The tilling device is called the electric mole, and it has won several awards worldwide. It is essentially a blind mole, and it has a microprocessor on board that gives it logic on how it is to cover the floor of the chamber, level, and partially distribute the sludge and mix the wet from the bottom to the top. The Class A process is achieved through the batch process, and Parkson has designed several and achieved Class A biosolids in many facilities. And this is a list of the facilities that they have designed and installed. This is a view from the inside of the chamber, and you can see how the water would be moved from the biosolids into the air and out of the chamber. This is a view of the actual solar dryers that would be the glass Venlo design on the first picture, and then the polycarbonate on the second, giving you an idea of what it looks like from the inside with the different building materials. This is a picture of the largest solar dryer in the world, and this is in Spain. THERMO-SYSTEM did this one, and this one has a loading hall and air scrubbers on it. Loading the solar dryer can take about an hour to 2 hours per batch. So it's taken from a central discharge, probably from a press, to the front end loader carries it into the solar dryer, and it's evenly distributed. The door is closed and the PLC takes over. Once you have entered your dry solids content into the PLC, the core algorithm takes over to tell the system how much the fans need to run, how much the mold needs to run, and the process is fully automated. It takes 1 to 3 weeks to dry a batch, and the average mass reduction is 70%. There is remote monitoring capabilities with this system. The operator can monitor the progress of the chamber's drying performance from any location. This is a screenshot of the SCADA view, and you can see the ceiling fans and the different banks. You can see the exhaust fans. You can see the inlet flap and what position it is in. You can see the dry solids content and what the mole is doing, and monitor the door. The tilling device is part of the automated process, and it is utilized to freshen the sludge and to bring the wet sludge from the bottom to the top. And you can clearly see the trail that the mole has left in the biosolids here. The movie vents are the ceiling fans, and they are more similar to an oscillating fan that allows the sweeping motion to break the moisture barrier along the top of the sludge. The forced convection system, which is achieved by utilizing the movie vent, is illustrated here with the yellow arrows pointing down towards the sludge, so that the air, the warm air collected in the ceiling area, is forced upon the sludge surface evenly. And this is a depiction of the moisture barrier being broken. The automated sludge drying essentially reduces the amount of sludge by 3/4. So you have a mass reduction of 75%. Unloading the solar dryer takes less time than loading it, and on average it'll take about an hour. So once the computer has said, okay, it's dry, the operator opens the door, drives the mold to the side, and begins unloading the chamber with a front end loader and loads it into a truck or a spreader for final disposal. The THERMO-SYSTEM is a green sustainable technology. It consumes very little energy, has low operating costs, has flexible modes of operation, so the amount of sludge and the percent solids of sludge that you can put into the chamber can vary from batch to batch, and the actual equipment does not have to change. Class A sludge is possible. If Class B is desired, that is also an option. And with this process, you get the maximum disposal options possible. If you would like any more information, please give me a call. My name is Julia Bealsmith, and my number is here on the screen. Thank you.